Hello, hello. My name is Zach, and I'm an engineer here at Flox. So today I'm going to show you what Flox is, how to use it, and how Flox do what it do. So let's go ahead and dive in. So what is Flox? Flox is at its core a package manager, but it's a package manager that, in my opinion, has superpowers compared to apt and brew. So what do I mean by that? So Flox has this concept of environments, and environments are essentially different scopes that you can install packages to. So you can have an environment for each project that you're working on, and at the same time, you can have an environment that's kind of always available. We call this the default environment. So this default environment is what you can install kind of system level dependencies to. So things like Git that you want kind of always available, and then you go to work on a particular project and you'll have a separate environment for that. You can install those project specific dependencies too. This could be your language tool chains. It could be, any kind of random tools that you need to work on either your work project or your hobby project, whatever the case may be. People will often use containers or virtual machines for this use case, but those can be kind of heavyweight and they come with some downsides that we'll get into at probably another time. But the icing on the cake here is that Flox does all of this while being reproducible and being cross-platform by default. So you can take your environments from machine to machine, operating system to operating system, or architecture to architecture. So it's enough jibber jabber. Let's dive into some examples so you can see what it's like to use Flox. So let's see what it looks like to get started with Flox on a brand new project. So for most projects, I would start by initializing the Git repository. So I'd say git init. And similarly with Flox, you say Flox init. So this creates a new environment called from scratch. This is taken from the name of the directory. And it gives you some breadcrumbs to see what you're supposed to do next. So let's say that I want to install Python for this project. So first I'm going to do a Flox search. So we're going to say Flox search Python 3. And it will show you a bunch of different Python versions. So these are actually different packages. And within each of these packages, we have different versions. So, as for each major Python version, there's a bunch of different point releases. So let's pick Python 3.12 and see which versions are there. So we're going to say Flox show rather than search Python 3.12. So you can see we have a bunch of different point releases going all the way back to alphas, betas, and release candidates. So this is really useful for kind of like enterprise or big projects, because that with Flox, you can actually install two different Python versions side by side and say that there's a new release coming out soon. You can actually install both the version that you're currently on and an upcoming version to test against the upcoming version to see if you're going to experience any breakages. So next we're going to install Python 3.12. And you can see that was pretty quick. So the next thing we're going to do is, there's also an uninstall command that looks how you would expect it to look, but we're not going to get into that. So the next thing we're going to look at is what we call the manifest. So when we do a Flox init, it actually creates a .flox folder. So you would store this .flox folder in your source control. So we're in a Git repository, so we can say git add .flox. And you can see that it created a few files for us when we did our Flox init. The only one that you really need to care about is this manifest. So when we do things like install, uninstall, these are imperative commands that are modifying a declarative config file, and that's this manifest.toml. So you can edit this manually as well using the Flox edit command. So let's look at that next. Like I said, now we're going to look at the manifest. So we do that with the Flox edit command. So let's go through the sections kind of one by one. So we have an install section. This is where you list the packages that you want to install. That's why our Python 3.12 is here. I'm going to uncomment this and it will install the hello package. So let's do that and see what happens. So it says it rebuilds the environment and it says, it's successfully updated. So what this is doing is it's transactionally building your environment to make sure that when you make edits manually, it's always left in a known good state. Either the previous one, if there's an error, we do give you an option to continue editing in case you made just like a small typo somewhere. But you can always bail and just say, no, I didn't mean to make any edits, in which case it will revert back to whatever the previous state was. So if we say Flox list, we can see what packages we have installed, and we now see Flox, or we see hello. So let's go back to the manifest. The next section is Vars. So when you activate, you're put into a shell. And this Vars section allows you to define environment variables that are set in that shell. So let's go ahead and set one of these. I'm going to say foo equals bar classic. So it's going to rebuild again. When I say Flox activate, echo foo, you'll see that bar is now set. So we're going to exit. Go back to the manifest. So the next two sections, this hook and profile, these are there to allow you to script what happens at the startup of the environment. So because, as I mentioned, you're put into a shell, what shell you're using will affect like what shell dialect you need to write your scripts in. And so that supporting a range of different shells can be tricky and error prone. So with this hook section, we say this is always run in a bash shell. And so that allows you to know that there's kind of a common denominator. There's only one shell dialect that you need to know. And so let's go ahead and write one of these on activate. And we're going to use the var that we set up there. We're going to say echo hello foo. And you'll see that when I activate this time, my script runs and I see hello bar. So again, let's exit. We're going to go down to profile. So this profile section allows you to write scripts that are sourced by your end user shell. So when we activate, we go through a bunch of bash stuff, and then we exec your shell, and we will then run whatever these scripts are. So this is useful for setting aliases and running any other logic that is otherwise shell specific. So for instance, if you use Python virtual environments, you have to source and activate script. And there's a different one depending on which shell you're using. And so if you want to say when you activate, always enter the virtual environment, you would write that logic here because you would have to source a different script depending on what shell you're in. So I'm just going to say, because I am an enlightened fish user, I will use the fish option. And I'm just going to say echo hello from fish. And again, I will exit. Oh, not exit. Activate. And you can see now I have both scripts running, one after the other. So let's exit that. So the next section is services. So if you've used containers before, you're probably familiar with Docker Compose. And so what that does is when you fire it up, it starts up multiple containers. And so this is useful for local development if you want to set up a bunch of services that, say, the project that you're working on depends on in production. So say you need a load balancer, a web server, a database, that kind of thing. So the services section is where you define those. So I'm just going to create one that sleeps. So I'm going to say sleeper.command equals sleep 999,999. So now if I want to run that service, I say Flox activate -- start services. And so I can say Flox services status. And it tells me that my sleeper service is running. You can also view the logs, but since this is just sleeping, there's no logs to see. So now I see this PID. So once I exit, it will actually stop that program. So if I say ps-a, we're not going to go through that. We're going to do this again and use ripgrep like a civilized person. You can see that there's no service running that has that PID. So when I exit my shell that has services running, it will automatically clean those up for you. And that is awesome. And I worked on that and it was hard, but I do it for you. So the last thing is this options section. So these are options related to like how the environment functions. So we have one called CUDA detection that will automatically detect CUDA libraries on your system and then link those into your environment so that essentially CUDA automatically works for you. So that's on by default, so we're not going to mess with that. The other setting here is systems. And so systems is essentially an allow list of what systems you need your packages to be compatible with. So Flox is cross-platform by default, and that allows you to take the same environment and give it to another developer, regardless of kind of like what system they're on, and know that it's going to work the same way. However, sometimes you need packages that are kind of system specific. So say that you're on, say that I'm on macOS and you're on Linux. I probably want Clang, you probably want GCC. I probably want LLDB, and you probably want GDB. So you can do all this stuff as well. So I'm going to show you what that looks like. So we're going to bail out of this. I'm going to say Flox install BPF trace. So this is a package that's only available on Linux. And it will give me a warning saying like, hey, that's only available on Linux. But rather than just failing, it will install it for just those systems. So if I say Flox edit and look at the manifest, you'll see that I now have a new line for BPF trace, and it will say, I'm only available on Linux. And so I'm on macOS. And if I list the packages, you see there's no BPF trace because I'm not on Linux. And so you can use that mechanism to install different packages for different systems. And that's actually very powerful for ensuring that everybody can use the environment. So I think that brings us to a close for looking at the manifest. So the next thing I want to show you is what it looks like to share environments with Flox. So we have a service called Flox Hub, and you can push environments to Flox Hub and then pull them in order to share or reuse them. So we're going to take the environment that we currently have and we're going to push it. And so you can see it says Flox pull in order to use this. So we're going to copy that. We're going to delete the copy that's in our current directory. Delete. And so now we're going to pull this environment. Oh, Flox, I have to give it a name. Z Mitchell from scratch. And so now this environment is linked with the one that's on Flox Hub. So if I make edits here, I can push them up, and anybody else that is using this environment could pull those and update their copy of it. So let's make a kind of trivial edit. So let's say ripgrep package path equals ripgrep. This is going to rebuild that. Flox push. And now the copy of the environment that's on Flox Hub is now updated. And if I were to pull again somewhere else, I would now have ripgrep. So that allows you to kind of make sure that anybody using this one environment is kind of on the same page. And so that's very useful. However, my favorite way to use this is to use it as kind of like a template for various projects that I work on. So I'm going to delete this environment and show you how I use it. So Flox pull -- copy Z Mitchell Rust. So I do a lot of Rust programming. Flox is written in Rust. I work on Flox, therefore I do a lot of Rust programming. I also do a lot of Flox programming, but so I use Rust a lot in my side projects. And so I have an environment that provides me kind of a basic Rust toolchain. And so rather than pulling this down and having something that's linked to Flox Hub, I'm just going to pull a copy of it that's not linked and use that as like a starting point for a particular project that I'm working on. So if I make updates to it, I don't have to push those up to Flox Hub because I don't care about that. So Flox pull -- copy, name of my environment. So now if I Flox list, you can see I have a bunch of Rust stuff in here. And so that's how I use Flox Hub mainly, is to essentially store templates for starting projects. And so now not only can Flox replace Docker, virtual machines, Homebrew, it can also replace tools like Cookie Cutter if you're using those to kind of like bootstrap projects. This brings us to a close with the intro to Flox. As you can see, Flox can do a lot of things. It can replace a lot of tools. If you're using something like NVM to install different node versions, Flox can do that. If you're using something like Homebrew to install dependencies on your system, Flox can do that as well. If you're using Docker to manage project-specific dependencies and make sure that everybody gets the same versions of stuff, Flox can do that. If you're using Docker Compose to make sure that you have services running for your development environment, Flox can do that as well. So give it a try. Let us know what you think. We have a community Slack where you can kind of engage with us. We're very responsive over there. So if you have feedback, we'd love to hear it. Thanks for checking it out.